Hello, welcome to the Sigma Made Simple channel. This channel is dedicated to explaining the principles of Lean Sigma and Six Sigma to anyone with little or no knowledge but wish to make improvements to a measurable process. My name is Dennis Wells, and I was learning about these tools even before I was certified in 2008 as a Six Sigma Black Belt and a Lean Sigma Green Belt in 2009. I have acted as a Master Black Belt, where I mentored many engineers for their Black Belt certification, trained personnel, mentored interns, and trained managers on these tools. Even in semi-retirement, I continue teaching and learning as I believe in the power of these tools when applied properly. That is what I want to show you on this channel. This video will show you how to create a value stream map. So, like I said in this video, we're going to show you how to create a value stream map. But before that, I want to spend a little bit of time talking about some production and some product types because they can affect how accurate your value stream map is. And then after you and your team decide on a product line that you wish to target, I'm going to show you the best method for creating the value stream map for the first time. I struggled with this a little bit because I was taught a different way, and I'll explain why in a moment here, but I decided to give you the end result instead of going through a lot of what I used to do and what lessons I learned. If you want to read a book, here's a great book. It's called Learning to See. It's a book I recommend you purchase and read. It's got a lot of great things in there. There's a lot of things in this video that aren't in there. So that book, along with this video, is probably going to do the most good for you. So when I did my first value stream map, I was very lucky because it was basically the easiest manufacturing line that you could have. It was a high volume, high visibility, low variation, low complexity. And you might be asking, what does that mean? Well, high volume is basically we had like 24 weeks of product to build. We had months of product, but the customer wanted it faster. Low volume is something like you only get a few days or maybe a week or two, and you have to switch over to another product, maybe even just a few hours. That'd be low volume. High visibility is when the customer is giving you plenty of notice in advance. Say, I'm going to need this in 6 months and I'm going to need this amount. That's not very common, but it can happen. Low visibility is when they call you up and say, I need this yesterday. So low variation is when the operators are using the same materials, processes, and specifications for a full day or more. If they don't have to change anything they're doing, I would consider that low variation. I consider it high variation if at any point in one day they have to make a decision to change materials, change processes, fixtures, specifications. So complexity is something that I kind of figured out on my own. I don't know if anybody else is teaching you this, but the complexity was low. This value stream map series is going to be more of a conglomeration of my 30 years of manufacturing. It's not going to be specific to any company. The numbers are not related to any company. Some of the workstations might seem familiar. I picked this product, which is basically a connector on a fiber cable. It's a single connector on a single cable. That's low complexity. And I picked this because it has the most variation when you're creating value stream maps, especially when you get into high complexity. So I'm going to go on and talk a little bit more about low complexity. So the nice thing about low complexity is when you have a roll throughput yield of 90% at the connector level, um, your probability or your rework free probability is equal to your roll throughput yield, 90%. Now, the opposite of that is high complexity, and that would be a single cable with two connectors. Now, what's unique about this is if there's one connector that's bad, they're both bad. So now you can see why it's high complexity. So this means if your roll throughput yield is 90% at the connector level, and you've got two connectors on the same cable, then your probability or your rework free probability is only 81%. And that's basically 90% to the power of 2, which is the number of connectors. That's important. Maybe not as much when you get to 2 connectors, but there could be instances where you've got 100 connectors on a cable. And in that case, even if your roll throughput yield is 95%, your rework-free probability is less than 1%, which means you're going to have a lot of rework. Well, not a lot of rework, but you're going to have a lot of non-working WIP traveling around that needs to have at least one connector worked on. And you need to pay special attention to this because this can severely extend your ability um, to get this product out quickly. It can take your lead times up 5, 10 times. So you need to be aware of this and just ask yourself. Hopefully you don't have high complexity, but that's probably one of the worst things you can have is a high complexity product. So after my first value stream map and my certification, like I said, uh, that manufacturing went away, and then I was dealing with a line that was actually low volume, low visibility, high variation, high complexity, and I started learning basically what those things mean to a value stream map, and that's where this enhanced value stream map came from. And then a value stream map is no different than anything else. If you can't measure your manufacturing with your value stream map, then you can't improve it. It just goes back to the old Six Sigma, Lean Sigma principle. That's if you cannot measure it, you cannot improve it. But this enhanced value stream map, you can. So I'm going to bring up the template that I created, and before any meetings, ask management the following questions: Who's going to be my champion, my stakeholder, my leader? What product, or put the date down in here. What product am I going to use? This is a made-up product. And then what my focus line area is going to be. If they have any historical data, go ahead and put it in here. I'll be checking it later. How many hours? Now this is important. If you've got 2 shifts that are 8.5 hours each, that's a total of 17 hours that's available for those personnel. But they take breaks and they go on lunches, and it's about an hour per shift. So they're only getting about 15 hours of actual daily working hours, and that's an important number here. Put that in here. If you have finance in the room, great. Put the labor rate in here. It's just usually the direct and fringe. You're going to use that for calculating your lost labor, what you're going to gain back from your lost labor. So we'll come back to that via value stream map in a minute, but it's going to target a manufacturing line making high volume, low variation, high visibility, low complexity product. A few days before the meeting, you're going to want to walk the line from the end, like we taught you before, to the beginning, whatever is closest to the customer. You're going to start there, and you're going to walk your way to whatever's closest to your suppliers. While you're doing it, talk to the operators. Tell them that we're doing a lean program. A meeting is going to be held soon. And yes, I do suggest that you have a meeting for your first value stream map for every product line, and that they're going to be part of this meeting. Ask them to think of things that would make their job easier and improve things between now and the meeting. And you might be asking, why are we going to have a meeting? Management might be asking that. They might be asking you that. Well, if this is your first time doing a value stream map, then you're going to do this to show production personnel that you are serious about Lean Sigma and their participation is important. Production personnel deal with issues daily. They have had the most time to think about what's going wrong and a better way of doing things. So after the initial value stream map for a product, you can keep it updated without the need for a meeting. So you bring all the personnel that work on the target product lines in for a 1 hour meeting. One shift would probably be fine, but if you've got 2 shifts, I'd try to include both, do 2 different meetings or do one big one with the overlap if you feel like it or if you can. It shows commitment to the process and it shows that you value that all of their opinion. Plus, For different shifts, you're going to have they have different needs, different opportunities. They have a different way of looking at things. You'll probably be amazed at the variety of information that comes from each shift. And neither one's necessarily better or worse or more accurate or less accurate. And lastly, when you think about this, if you take 1 hour out of a 40-hour work week, that's only 3% of your production time in a week, and you will make that time up even quicker if you do keep these people involved. And if you do this process to show them that you're serious about it. So the next video will be one you can show at the meeting, at the beginning of the meeting, or just take some notes and basically say the same things that I say in that video if you don't feel like showing it. It's about 8 minutes long. So after the introduction video in your meeting, and then I do suggest you do a quick brainstorming session. You don't have to if you've already done one. I suggest you do. You can get some low-hanging fruit probably pretty quickly. Um, use the EIC tool, and then you're going to use post-it notes to identify the workstations and gather the data. Again, always start at the workstation level, and it's easily identified as a workstation level as the product changes, as the product is moving from personnel to personnel. Each person basically is working at a workstation. So put the first post-it note on the far right of your wall at the head of the meeting, and then work to your left because you're going to start at the end and you're going to work to the beginning. Post-it notes you're going to find are going to make things easier to make changes if you want to or to move things around. I'm going to pull up this value stream. Oh, actually, I'm going to go to here, and then this is a post-it note. In the middle, put the name of the workstation. Here it's pack, short for packaging. The upper left is 600 seconds. That's the cycle time. That's the total time that it takes in labor. All right. That's very important. If you've got two people doing something and it takes a total of a minute, it might only take 30 seconds to get it through. Make sure you're capturing the total time because this is going to be used to calculate your costs. All right. So put the total time as 600 seconds. Now, it can also be hard to get people to agree when you got a room full of people. How long it really takes. Um, Ask somebody that's a subject matter expert that does packing all the time. Ask them how long does it usually take? If you can't really get an agreement, start with a number. Start with like 10 seconds, and then keep going up until everybody that kind of does that job kind of says, yeah, that sounds about right. Remember, you're not trying to get it perfect. What you really want to do is you want to just gather information really quickly. You want to show them that that their input is important to you, and you want to show them that you're serious about this process. But in the end, you're not going to have the perfect information, but what you're going to have is information that's good enough so you can see the bottlenecks. And I'll show you that in a few minutes, in another minute. So then you ask them, how many connectors do you package in that 600 seconds? And they might package 40 connectors. So you write that under the 600. In the upper right, put the first pass yield. In this case, it's probably going to be 100% since they don't really do much inspection. They're just packaging things up, and they probably don't report much non-conforming product. So, and on workstations where there is maybe non-conforming product and people can't really agree, just start at 99%, work your way down until everybody kind of agrees. Again, you're just looking for a ballpark. You're going to find a large amount of variation. It's going to be easy to find those bottlenecks. So this is an odd workstation since it's actually an area, and that's why I put this in here. When I show you the value stream map, I'll explain what a normal workstation would be. But this is a workstation. It's actually a work area, and they have 6 workstations, and they support 32 lines. So it'd be 630 seconds of a workstation. And then they've also got 12 people. That's basically 2 per, and it's 32 that they're supporting. There's nothing wrong with putting fractions in here. It's going to help you keep track of the support areas at the beginning and at the end of the line to make sure that when you start making your changes and your outputs start going up, that they're capable of supporting your higher outputs. So in this case, it's a value-added activity. I consider packaging a value-added activity because the customer wants to get the product intact. I think if I was a customer, I'd be willing to pay for good packaging, nothing extravagant, but packaging that's going to get it to me in good condition. Others might disagree with packaging being value-added. Some people might say it's non-value-added required. I'm not going to argue about that here. If you don't agree with me, just put your opinion in the comments and we can start a discussion. Under that, record where the non-conforming product goes when it's found. This can also be left blank if it's 100% especially, but I just put that in here just so that you kind of know where it goes. In the lower left, you can calculate any planned downtime or changeover time in seconds per hour. Now, this is nothing like lunch or changeover. This is like maybe this particular workstation shuts down for 5 minutes an hour to do some kind of a settling. So like if you have to reference your equipment every hour for 5 minutes. You just put how many seconds per hour. If it's 5 minutes every 2 hours, then you take 5 minutes divided by two. So it's that amount of time. That's basically the seconds per hour. And like I said, don't take into account lunches or breaks because that's taken into account in another area. So lower right, ask them about how much product is waiting for them to do their job. And then finally, ask them what has to happen in order for you to get that product to package it. And they'll tell you what workstation's immediately before them. And you go to that workstation and you start collecting the information there. And then keep putting those post-it notes up. So after collecting all the initial information, we're going to put this in the enhanced value stream map. If you'd like a copy of this enhanced value stream map, just email me. I'll send you a copy. I don't mind sharing. We're going to look at this and I'm going to go through a few notes. You'll notice we've got all this data in here. This is on the base data tab. It's going to do a lot of calculations for us. We go to the current. Here's what we just did with pack. Okay. And then you might notice over here for pot, it's got 2 workstations, 2 operators, 160 seconds. So again, units, how many units are you going to pack? Are you going to process in that period of time? They're doing 40. And that cycle time, here's the cycle time. It's the total seconds and labor that it takes to do the job. Downtime again is any planned downtime other than lunches and breaks. Workstation count. So they got 1 prep station, they've got 2 potting stations, 1 polish. Total number of operators, 2 operators, 2 here, 2 at polish, 1 here at geometry, 1 at crimp. First pass yield, not a lot of bad data here. It's pretty good. And then your non-value added. Now, you did ask where rework went back to. I'm not going to put that in here right now. I'm just going to move forward with some other things before we get into that. So line 11 would be where you would put the rework where it goes back to. You just put the number in here, like let's see, like for this product here, let's say it goes back to 3, and that's basically the number at the top. And then here 3 as well. And then let's say this goes back to 1, and then let's say this goes back to 1 as well. And then you put down if it's online or offline, that's your rework type. Online means that it's going to stay on the line, and we're going to just kick it back upstream. That's a common way of doing things, but with complex product, it can become a nightmare for your ability to get that product out. And then in your materials here, material costs. This is the cost if something comes back to this workstation. This is how much you're going to spend in addition to what you've already spent to rework that product. And then that's going to be important. You don't have to have that yet. You will want to get it at some point so you can do your cost savings estimates more accurately, which this spreadsheet will do for you as well. I'm going to come back over here and I want to show you something. You see the output that was given to us was 390. And then if you come down here, this says with the data that we've got, that the value stream map takes into account all the information that we put in there. And it says we're only going to get 285. So this is not usable. If you look at cell, this row here, C21, it says it's not usable. Look, if you can get within about 10% this this output and this output are within 10% of each other, then you've probably got something you can work with. But if they're not within 10%, then I'd go back and find out why. And the reason why is we're going to start using an eye chart to start collecting data and looking for a change. Because when we implement something, we want to know that if it's made an impact or not. So we want a value stream map that can measure it. And eye charts are an excellent control tool and an excellent tool for this. They can detect major changes as well as small changes. The next video is going to be an explanation of what a histogram is and what an eye chart is and how they're related. After that, you're going to have a really good idea about why I use eye charts. And then the following video is going to be how to verify and clean up the data. Like get these two data here to be within 10% of each other. And that's not hard to do either. You um, just have to look at the data and use the principles of a control chart to look for what we call special cause variation. And I'll explain that in another video as well. So I added some formulas in rows 14 through 22. I'm going to jump over there really quickly, and I'm just going to open up right here. This is the most important thing. This is your workstation factor. Your workstation factor takes into account all the information up above. And so, like you'll see here for polish, it says here pack was your bottleneck, but then it didn't take into account all these other things that are going on. And actually, you look at polish, if it's 160, 122 over here for loss. Once you take into account that you've got two people or you've got one workstation, 165 seconds, you've got a lot of rework coming back to you because um, this one, geometry comes back, crimp goes through there, loss goes through there. If we were to take this out, let's take these rework things out and just see what happens. Okay, it still has polish as your bottleneck. So, one of the purposes of a value stream map, of course, is to look for your bottlenecks. I'm going to go put that information back in here. And what we really want to do is we want to find the main bottleneck, which is polish. We want to look up what's going on there. There's one weird thing too. If you look at polish, if you look at the first pass yield is 94%, it's in the pink cell. Then right below that says it's value added. So why is it value added? That's really weird. Um, uh, so we should probably look at that. And now you got a similar situation over here with crimp. It's not a bottleneck, but it's got a 98% yield, and it's also got a value added activity here. So why is that? So we'll probably want to look at that. If we look at geometry, that's the next bottleneck. It's 158. So we want to collect more data on polish, geometry, crimp, because we don't understand what's going on with this, and probably loss. So we're gonna go out and just get some more information on those areas. So we're gonna go back and look at polish to see why it is a value-added activity, but it has 94% first pass yield. And if the operators have any ideas about what can be done to improve, we're going to do the same thing at crimp. Why are we at value-added activity? It has a 98% first pass yield. And if the operators have any ideas what can be done to improve, we're going to look at geometry to check out that cycle time. I will also be checking the cycle time on polish. I forgot to mention that, but we'll be checking the cycle time on that because we want to be sure that we've got these top three bottlenecks identified properly. And then loss. And we want to look at loss. We want to make sure that we've got the information for loss, the cycle time there as well. If you notice the other workstations, the workstation factors 85, 83, 82, and 80. So we probably don't need to do much with those, but all of these, actually even crimp is even lower, but we just want to find out what's going on with this value-added activity here. So really, if you don't have anything weird like that, like the value-added activity, you'd probably only go back and look at these three because they're the top three, and you want to get those right. So after we're done with those investigations, we'll look at what's what we should do next, or if we can make some changes. So we've created a value stream map, found the workstations that we need to spend more time on. And the next video is going to be an introduction video for your first value stream map meeting. Show it to your team at the beginning of the 1 hour meeting to introduce value stream maps, do a quick brainstorming session, build your first value stream map. It'll explain why you're bringing everyone into the meeting. And after that, there's going to be introduce the power of histograms and eye charts. That video is going to show you how to detect changes and maintain improvements. The way you do that is by minimizing your standard deviation, which the next video is going to show you how to clean up your data, historical data. And if you don't have historical data, then you can collect it. Just make sure that you're running those lines fully manned, fully loaded with work, and fully loaded with materials. And just pick one line. Even if you've got 10, just remember, just pick one line and make the assumption that if you make improvements on that line, that's going to make an improvement on the others, especially if you make a eye chart for line 1, and then you put that same eye chart on line 2 through 10, and they're outperforming or underperforming, you can look at what's being done differently, and you probably have to do it by shift as well. But that other video will go through that. Then we're going to come back to this value stream map that we created here, and I'm going to show you what we learned when we went out and investigated those things, and I'm going to show you the new output when we put that in there and what the output is when we learned more information about the bottlenecks. So if you found this video useful, like it, subscribe to the channel, and share it with anyone else who might find it useful. If you didn't find this video useful, then subscribe in the hope that an upcoming video will be. Eventually, we're going to go through projects using the Lean Sigma and Six Sigma tool, as well as the tools needed to support them. Remember, if you cannot measure it, you cannot improve it. A value stream map is no exception. We'll see you in the next video.